Hi everyone. In this video, we are going to discuss how to find out the minimum and maximum values of a quadratic function. And also we'll see how to find out the coordinates of the vertex of the parabola. We know that every quadratic function is like a parabola when plotted on the graph. And through algebra, we are going to see how we can determine the maximum and minimum value of the quadratic function. Now, before we go into the algebra, I wanted to build the intuition from the quadratic function graph just to show you that when a is positive, we know that the parabola opens upwards. That means in this case, the maximum value will be positive infinity and the minimum value will be whatever is the value of the function at the vertex. If you carefully look at it, this will be the minimum value right here at the vertex. This will be the value of the function at this point, the value of the function at that point, that is the minimum value. And the maximum value will be, of course, positive infinity because the parabola goes towards the positive infinity. When the leading coefficient is negative, we know that the parabola opens downwards, and in that case, you can see that the maximum value will be actually whatever is the value of the function at its vertex. That will be the maximum value. So in this case, it's kind of interesting. Here you see the maximum value will be at the vertex. So this is wherever the vertex is on the function, the value of the function at that point will be the maximum value for this graph. So I'm just simply writing it here max. So the maximum value of the function will be at the vertex. And what will be the minimum value? Well, the graph extends all the way towards the negative infinity. So the minimum value will be negative infinity, right? So when the leading coefficient is positive, the minimum value is at the vertex and the maximum value is positive infinity. And when the leading coefficient is negative, then the maximum value is at the vertex and the minimum value is negative infinity. Now, with that in mind, let's now try to do some algebra and see if we can somehow figure out what should be the minimum and maximum value of a quadratic function like this, like ax squared plus bx plus c, right? So let me scroll down. So our original quadratic function is like this. So let me say f of x is equal to ax squared plus bx plus c. Now, can we write it like this? It's exactly like how we derived the roots of a quadratic equation. There is a separate video that I have done to show you how to determine the roots of a quadratic equation through the quadratic formula. In that video, you will also see the same steps, and here I am going to kind of repeat the steps to some extent. So here, if we take a as a common factor out of this quadratic expression, so if we say a is out now, so we are left with x squared, and then on the second term, we have to divide by a. Then it will be b by a times x plus c by a, right? So our quadratic expression actually now going to look like this because we have taken a outside the bracket, right? So now let's continue. So if we have a here, and then we can say, okay, this is x squared plus we can say 2 times x times b by 2a plus we are now going to add a new term b by 2a whole squared, and we're going to subtract it also, b by 2a whole squared, because we didn't have it, so we added it and subtracted it to keep everything in balance, and then plus c by a. So our quadratic expression looks like this. Now from here we can say, okay, this is a times, if you look at this portion right here, this is now x plus b by 2a whole squared. So we are going to write it as x plus b by 2a whole squared, and then we have these other terms which are like, we have negative b squared. Now I'm going to remove the parenthesis there, negative b squared by 4a squared, and also we have positive c by a, right? Let's simplify a little further, and so this will be equal to a times, we have x plus b by 2a whole squared minus, let's take the LCM here, LCM would be 4a squared, and it will be then b squared minus, because we have a minus sign outside of this fraction, so the c by a term will become negative, so then it will be 4a squared by a, that would be 4a, so 4a times c, that would be 4ac. Now from here we can say, okay, So this is, now let's bring a inside the bracket. So now I'm going to bring a inside the bracket. So it would be a times x plus b by 2a whole square minus, for the second piece here, you see we have b square minus 4ac, b square minus 4ac, and we have 4a square down below. In the denominator we have 4a square, and if we multiply that entire term by a, then in the denominator we will be left with 4a instead of 4a square, right? So this is equal to a times x plus b by 2a whole square minus, now if you see on the fraction we have b square minus 4ac. Well, b square minus 4ac is actually the discriminant. See this portion, this is actually the discriminant of the quadratic function, right? So now we are going to write it as discriminant. So we are going to write it as d divided by 4a. All right, I hope it's clear up to this point. Now before we go into the further discussion, we need to understand one very important property of real number, and from there we are going to develop an inequality, and from the inequality we will show that the minimum value of this quadratic function or the maximum value of this quadratic function will be something that will derive now, right? So let's talk about this very important property of a real number, which is kind of like this. Any real number, the square of any real number is always non-negative, meaning it is greater than or equal to 0. This is an extremely important inequality that we have to remember always in maths. If you are talking about real numbers, not complex number, we are talking about real number. When you talk about real number, then the square of any real number is always greater than or equal to 0. Now with that in mind, what I am going to do, I am now going to take advantage of this, and I am going to say, okay, if that is the case, can we write it like this then? If we use another real number here, for example, I am going to use x plus b by 2a, and I say whole square of this, that also must be greater than or equal to 0, because x plus b by 2a is also a real number. If we square it, that will also be non-negative, it will be greater than or equal to 0. And then if we take a case, suppose now I am taking a case where a is positive, our leading coefficient is positive. Now for this case we are going to analyze this thing first, right? So let's take this case, a is positive. Now when a is positive, I am going to do this little trick here. When a is positive, I am going to multiply both sides of this inequality by a positive number a, right? So I am now going to say, okay, a times x plus b by 2a whole square, that is also going to be greater than or equal to 0. Well, 0 times, let's say 0 times a, right? So we can say that this is going to look like this, that a times x plus b by 2a whole square greater than or equal to 0 times a is 0. So now you see that we have been able to establish an inequality where we are starting to see part of the quadratic function that we started with. You see our original quadratic function is kind of like this. This is our original quadratic function, and we are starting to see part of it coming up in this inequality, right? Now there is one more step I need to do. I need to subtract d by 4a from both sides of this inequality. So from here I can say, okay, let me now subtract d by 4a from both sides of this inequality. Then also the inequality should not change, the sign of inequality should not change, because we can subtract a particular quantity from both sides of the inequality and the inequality would still be intact, right? So here we say, okay, our original quantities are a times x plus b by 2a whole square. Now I am going to subtract, okay, so this was greater than or equal to 0, and I am going to subtract the d by 4a, that quantity d by 4a, I am going to subtract this quantity from both sides. So d by 4a here also on the right hand side, and 0 minus something, I can clearly remove the 0, because 0 minus something is negative of that quantity. So I can write it like this. Now from here you see that the quantity that we have here now, it exactly matches with our quadratic function, which was right here This is our quadratic function. And now if you look at this red underlined portion here, this is nothing but our quadratic function. Now I'm going to say that okay, so this is nothing but our quadratic function. So from here I can say that f of x, which is our quadratic function, must be greater than or equal to negative d by 4a. Right? So we are almost there. Now when is this happening? When a is greater than 0. That means when our leading coefficient is positive. So when the leading coefficient is positive, the value of the function must be greater than or equal to negative d by 4a. So what is the minimum value of our function? If it has to be greater than or equal to this, that means the minimum value will be equal to this. Maximum value will be any value greater than this. So the minimum value will be negative d by 4a. That means we can say that f of x minimum, so if I simply write it like this, the minimum value of f of x, so I can say f of x minimum, f of x minimum will be equal to negative d by 4a. Now if you think about our function graph that I had on at the top, and when a is positive, this was our function graph. So when a is positive, our graph was upward opening parabola, and in that case the minimum value of the function was at the vertex. So that means the value of the function at the vertex is actually negative d by 4a. The minimum value of the function that we just saw, that is actually negative d by 4a. So that is nothing but the value of the function at the vertex when a is positive. So here we can say, okay, the value of the function at the vertex is equal to, this minimum value is equal to negative d by 4a. So when the minimum value of the function is negative d by 4a, what would be the value of x? Well, let's now go back to our algebraic equation there, or inequality there. When f of x is minimum, in that case value of the function is negative d by 4a. That means we can say that our function, our original function, which was written as a times x plus b by 2a whole squared minus d by 4a, this was our original quadratic function, and this will be equal to negative d by 4a when the function value is minimum. So at the vertex, the value of the function is negative d by 4a. So now I am forming an equation. I am saying that okay, at the vertex the value of the function is minimum. That means the value of the function, so this is our function. So the value of the function, I'm making a yellow box here. The value of our quadratic function will be equal to this negative d by 4a, because we have already proved that the minimum value of the function is negative d by 4a, and that happens at the vertex, right? So from here what we can derive? Well, from here we can say that our a times x plus b by 2a whole squared is equal to 0, because you see that this negative d by 4a on the left hand side and the negative d by 4a on the right hand side, they're going to cancel each other. So then we are going to be left with a times x plus b by 2a whole square equal to 0. And then we can say, okay, now if we divide both sides by a, because a cannot be 0. A cannot be 0 because it's the leading coefficient of a quadratic function. A cannot be 0. So if we divide both sides by a, we are going to be left with x plus b by 2a whole squared is equal to 0 by a. 0 divided by a, which is equal to 0. And from here we can say, okay, then x plus, so now we are going to take square root on both sides. So x plus b by 2a will also be equal to 0, because square root of 0 is 0. And from here we can say, okay, then x must be equal to negative b by 2a. So now you see, when the function is at its minimum, which is the vertex of the parabola, there the value of x is negative b by 2a. So where the function value is minimum, we have found two things. We have found the minimum value of the function, which is negative d by 4a, and the value of x, which is negative b by 2a. So now if I take you up there to the graph, and there you see that the minimum value of the function was negative d by 4a, and now I am saying that the x coordinate, which is a point right here, that will be negative b by 2a. So at that point, when x is equal to negative b by 2a, the value of the function will be minimum, and that value is negative d by 4a. That means the coordinate of the vertex would be like this. That means our vertex will be at, so the coordinate of vertex, so I can write it here, coordinate of the vertex would be negative b by 2a and negative d by 4a. I hope it made sense up to this point. And if you take the second scenario where leading coefficient is negative, there also you can prove that the maximum value of the function will be at the vertex. Use the same inequality. There the inequality sign will change as soon as we multiply by a on both sides. The sign of inequality will change, and then we will be able to prove that the maximum value of the function will be at the vertex, and that will again come out to be negative d by 4a. And the x coordinate will be negative b by 2a. So whether your a is positive or negative, in both the cases you will find that the coordinates of the vertex would be exactly like this. So in this case also the coordinates of the vertex would be negative b by 2a comma negative d by 4a. And let me highlight this. So this is going to be the coordinates of the vertex. This red highlighted box right here, that is going to give you the coordinates of the vertex, no matter whether your a is positive or negative. In both the cases, the coordinates of the vertex will be like this. Only thing you have to remember is that when a is positive, vertex is at the lowermost position of the function graph, and when a is negative, the vertex is at the highest position of the graph. But in both the cases, the coordinates of the vertex will be negative b by 2a and negative d by 4a. Also, we can calculate this via calculus. So let me quickly do a little math here for calculus. Say suppose let me use this space right here. So I'm going to be using this little space right here, and let's say suppose our function is f of x. So I'm going to write down the function. Our function was f of x is equal to ax squared plus bx plus c, and we can say this is y equals f of x. So now if we take a derivative with respect to x, the slope of the tangent at the vertex will be 0 because the tangent will be horizontal. So we can say dy by dx. If you know calculus, then you can do it like this. Dy by dx will be equal to, here it will be 2 times ax, and then it will be 1 times b, right? That will be the derivative. And now if we are talking about the vertex of the parabola, we are talking about a point where the tangent of the vertex will be horizontal, meaning the slope will be 0. That means this will be 0. So we can say at the vertex 2ax plus b is equal to 0. This is the slope of the tangent at the vertex. From here we can say that x is equal to negative b by 2a. And using this value of x, you can find the value of the function. It will come out to be, so if you calculate the value of y, it will come out to be negative d, where d is the discriminant, negative d by 4a. This will be the value. If you calculate it, you will see this value. So here also, via calculus, we can prove that yes, the coordinate of the vertex is actually negative b by 2a comma negative d by 4a. I hope everything made sense. Thank you for watching. See you in the next video.